worlds, and welcome to the future of gaming. My name is Nico. As usual, I'm your host. We have Tim Cotten, Matt, Dion, and David Amor with us. It's been a few faces that you've seen before, and today we are doing a bit of a jamming session. We, just before this podcast, were throwing around some ideas, what we would call this, because it's going to be pretty meta, because there's a lot of hidden information involved. There's a lot of emergent podcasting that's going to happen right now, because none of us really know what the conclusion will be and the point we're trying to make. But I had a discussion with Tim, when was this? Yesterday. And the stuff that he's building just suddenly clicked something in my mind. It was a problem that I hadn't solved, that I've had for a long time. And I've brought together the Avengers. Every single person on here, except for me, probably has something to do with these ideas and can do something with these ideas. And so that's where we're going to get at. The idea, or the name for this podcast initially, was God as a Service. And maybe we'll come out of this with a better name for this. But with that said, perhaps for those of you listeners that don't know the audience, the participants here, could you guys just give us a brief 2-minute background on you? And I'll go clockwise on my screen. So Tim, you want to go first?
Sure. Hey, I'm Tim Cotten. I'm the CEO founder of Scripted. We're working on AutoRPG, which is an autonomous AI system to build games in game worlds. I come from a background in MMORPG design. I got my start at Electronic Arts on Ultima Online, kind of in the middle generation there. And we were doing live ops before I think it was called live ops. So a lot of live events work.
Awesome. David.
David Amor, building fully on-chain games, autonomous worlds, with the team here in the UK. I think most people have heard before, so let's keep it short.
That's it. Matt.
Matt Dion, former product manager at EA, Jam City. I think we have we're all ex-EA folks here. And I run a research consultancy called Always Scheming, and most recently I started a newsletter called Dark Tunnels, which is dedicated to fully on-chain gaming.
Good. So fully on-chain gaming, Matt and we have a recurring call where we jam about everything that's happening in the fully on-chain gaming world. He and I, and Matt actually first introduced me to the concept of a mile, or a massively interactive live event. And he and him, and maybe we're the two only people in the world that see some value at the intersection of miles and fully on-chain games of autonomous worlds. But I feel there's something there. And so, Matt, would you do us the favor of just introducing the concept of miles, and then maybe also start bringing it into the concept of fully on-chain games, and where you think there's some interesting stuff to be done there?
Yeah, I will do my best. This is a topic that I've kind of evolved my thinking on over the last few years. One thing I neglected to mention in my intro is that I'm a contributor at Naavik also, and that's where I first learned about this concept of miles. Maybe a couple of years ago, I wrote a piece exploring this for the first time. There's a company called Genvid Entertainment, Genvid Technologies, that is sort of pioneering this particular format, and they created an experience with Facebook called Rival Peak. And essentially, to overly simplify here, Miles is short for massively interactive live events. And it's kind of an offshoot of cloud gaming, where let's say the virtual world itself is being executed in the cloud. It's not happening on my machine. It's not happening on Tim's machine. We are only interacting with it through basically like a streaming technology, like you would watch Twitch. So a commonly cited example here is Twitch Plays Pokemon. Twitch Plays Pokemon is happening on an emulator somewhere in the world, but we all can interact with it by sending the Twitch interactions to the game, and then it gets streamed back to us. Rival Peak was far more advanced. They had a bunch of basically like AI characters that existed in this virtual world. They're sort of like Lost, if you will. If you ever watch that show, they're kind of like stranded on an island trying to figure out what they're going to do. There's 12 survivors or something like that, and we as viewers, as participants in this massive interactive experience, can interact with the AI characters in different ways by playing mini games, by voting on what they should do next, by trying to influence the narrative and influence the characters' actions. And Genvid has gone on to do more of these experiences. They actually have a big one coming out soon. I think it's coming out on Halloween, actually. It's a Silent Hill mile. They've done a couple others as well. They did one with The Walking Dead, for example. So that's what miles are. And I sort of went down this rabbit hole. Initially, this was during the peak of cloud gaming and Google Stadia hype, and this was like kind of a what I felt was a more realistic offshoot of cloud gaming, like more achievable. And to Genvid's credit, they're still working at it today, and I think they're a really strong team, and I hope that they are able to push this medium forward. However, this was all before the blockchain bull run of 21 or whatever, late 21. And it was also like kind of in the middle of the pandemic, and there was let's say a quasi mile that emerged during the pandemic that really caught my eye, and I think caught Nico's eye as well, called Blazeball. Blazeball is a mile. It's a simulation that happens remotely, and then we can all interact with it. But it's basically like fantasy baseball, to sort of overly simplify. These games get simulated on a remote machine somewhere else, and then we, as viewers, as interactive participants, can bet on the outcomes of the game with virtual currencies. To be clear, these are not cryptocurrencies. These are just like Web 2 currencies. And by betting on the outcomes, we earn some currency that we can then use to influence the overarching narrative of the league of Blazeball and the players that are in the Blazeball league. So it's really absurd. It has these kind of crazy emergent narrative aspects that, and this is where I think we're going to get into some of the conversation later, this narrative is in part shaped by the developers and in part shaped by the community. So we have all these people watching and interacting. They get to choose, like, with some limited optionality, which way the story will evolve. And the developers are kind of offering these choices. So the example that I like to give is like one of the options they gave to vote on was open the forbidden book. And now there were a couple other options to vote on, but like, who's not going to vote on opening the forbidden book? What does that mean? What could happen? And so it's this emergent thing that happens. The developers don't even know, by the way, what's going to happen when they open the forbidden book. They have an idea of like how it will change things, but ultimately, like fundamentally, it's a simulation. It's all math, and it's a set of simple rules in the background that determine how the simulations will run and how it will interact with all the other pre-existing rules.
Okay. Can I Miles. Pause there, because there's one bit that I didn't understand, and I've watched some YouTube videos of Blazeball to get my head around it, and it seems amazing. But you said there that the developers are giving options for the players, but they don't know what happens if they were to choose one or the other of those options. But to me, that doesn't make sense. Like, if you create a piece of code, then you know what happens if people choose outcome A because you've written it, and you know what happens if people choose B because you've written it. And it's just a question of, I wonder which one they'll take. So, but you said something different there. So can you explain that?
I'll try. So it's a simulation game, ultimately. And so they might have some idea of how it will interact with the existing simulation, but there's some RNG involved, it's percentages. So it might influence things in this way, it might influence things in that way. They don't necessarily know with 100% certainty how it will change things. They also don't know how the community will react to these rule changes. Like, sometimes I'm struggling to come up with a specific example, but during the history of Blazeball, there were occasional strange like edge cases that emerged where, let's say, a number turned to 0, and it was an unexpected 0 or unexpected null value, and it like kind of like destroyed their logic in some like weird unexpected way, where there was a bug, but the bug became the feature, and the community built this lore around it to where the bug was now actually what was supposed to happen. So they had one where, like, I think players could be incinerated, or they could be like trapped in a peanut shell and unable to use them in the lineups. It's like really strange things that were like lore-driven emergent events that happened out of like bugs or unexpected reactions to rule changes or code changes, if that makes sense.
Another example, I believe, was, and you hit the nail on the head, Matt. It's like emergent gameplay around rule sets that are almost like that you're able to beat, or that have bugs in them as a feature more than as as a bug. And so I believe that one of them was players could die, but if everyone agreed or everyone voted for a dead player as player of the season, then that player, some value would become negative, and that would actually turn them back alive. And then, they would be dead, but they would be playing. And then and so the interesting thing, and I recommend watching the YouTube video of this. There's, I think People Make Games is a YouTube channel that made a video about this. It's called What is Blaseball and Why is it taken over the internet? I'll link it in the description. And it's just incredible. And just the emergent narrative that happens there is, I think, what inspired so much excitement around this. People were diehard fans. They created, X accounts, Twitter accounts back in the day. But Matt, I believe you were the one to tell me that they've decided to shut down Blaseball recently.
Yeah, they shut it down earlier this year. I think they had some struggles kind of continuing with it. I don't think the developers expected it to have the success that it did, and they weren't prepared for the content treadmill and the live ops cadence that they needed to keep up with to keep the game going. They also had planned to bring it to mobile, and I think they had some struggles doing that platform shift. I've actually spoken to Sam, the founder of the company. I hope I'm not misrepresenting him here. So Sam, feel free to let me know if I'm saying anything wrong here, but this is my read on the situation. And it's a bummer because it was it was a huge sort of pandemic phenomenon. When everyone was stuck at home, people could engage with this sort of fantasy world. And as you say, Nico, the really interesting part is the emergent community behavior that occurred. People, it's all text based, we should say. It's just, it all takes place in a UI. There's no images of the players, there's no images of the teams or the fields that they play on. And you can go and Google some of the fan creations. It's pretty incredible. And they built this lore around these teams and these players. And to me, that's where it gets really exciting when you think about on-chain games. And maybe this is too soon to segue. Tell me to stop if I am, but
go ahead.
On-chain games are inherently limited in terms of throughput, computation, power. And these are just really simplistic simulation games. It's all text, it's all UI. I think that fits really well with the headless, clientless nature of fully on-chain games as well. But it's really simplistic. And all of the craziness happens off-chain. It happens in the world, in the community, on social media, in the community. And so that's, to me, is really exciting, is where the emergent behavior, you don't have to worry about the limitations of being on-chain. It happens with the community that you're building, and blockchain gaming broadly and on-chain gaming specifically are so big on community building and establishing interpersonal relations and social conflict, and leveraging these to kind of add dimensions of gameplay that are not so easily bottable, let's say. I think that there's some really interesting overlap there.
Appreciate that. Thank you, Matt. Great summary, by the way. David, you introduced yourself as someone that builds on autonomous worlds. Mm-hmm. Could you just give us a brief background on what you mean with that? What are you building? And perhaps also maybe give us a brief definition or some context on what you define as a autonomous world.
Okay. First, to say that it isn't particularly well defined yet, so that's a contentious question already. But I suppose what's commonly accepted about an autonomous world is a game world, at least for the purposes of our conversation, a game world that lives on a blockchain. And by living on a blockchain rather than living on Amazon Web Server, then it's decentralized. It isn't owned by anybody in particular. It will live forever on that blockchain. And usually autonomous world has a fixed rule set, i.e. that the rules of that world can't alter over time. So an autonomous world is one that lives forever on a blockchain that isn't owned by anybody and has a set of rules within that world that don't change over time. And so that's different from, already there's some fundamental different things than typical games like World of Warcraft or EverQuest, etc., where those are live operated by Sony or they're live operated by Blizzard, and they can be changed, they can be turned off. There's no expectation they'll live forever. So using blockchain, you can build a game that lives forever with a fixed rule set that isn't owned by any one company. That's sort of a definition I think we all agree on. I also think that an important aspect is one where the players in playing the game can extend that game, can add creations of their own within that world. So that's, I suppose, my definition, a short version.
So we've been talking a bit about emergent narrative and emergent gameplay. Mm-hmm. How are you limited as a developer, David, while you're building on chain? Especially given that almost all games out there have some sort of hidden knowledge, and not knowing something and discovering something is in many cases part of the excitement of the whole game world. And so how are we trying to solve that within an autonomous world at this point?
Yeah, so there's two ways of solving that. One is you don't have hidden information, and I built PlayStation games for a long time, and I would have killed for the ability to have hidden information. It's just, maybe in the later days it was possible, but there's just no mechanism. Everyone's staring at the same screen. And yet we created games which were very, very entertaining, despite the fact that nobody had hidden information. So the first thing I'd say is it's not an essential part of game design. It's just a very useful part of game design. And if you think about all card games, pretty much all of those rely on the concept of hidden information. So in terms of game design, a very useful thing. Now, a problem with a fully on-chain game is blockchains, by definition, are fully open, transparent ledgers. That's sort of the point. So it becomes very hard to have hidden information in an on-chain game. So when we first started to build our second game, Downstream, then we made a point of saying, okay, well, there isn't any fog of war, and what one person discovers, everybody can see. And okay, it's hidden insofar as they can see it, but they can't actually get to it because they're at the other side of the map. But to be honest, that was a compromise when we did that. I think given the choice, a game designer would have liked to have that as an option for them to use. I think that since we've been building it, it's become clear that you can put a layer on top of an autonomous world and use zero-knowledge proofs for hidden information. So we're starting to sort of explore ideas about how you can build hidden information in on-chain games using zk proofs.
So when you think about what Matt described earlier, where you have a mile or miles, where there's a lot of emergent narrative based on, random things going on. What are some of the, right now, problems that you see with that? And, when we talked about Blazeball, a key part of Blazeball was the developers themselves injecting possibilities and changing the narrative as we progressed, right? Because every new season, every play match, I don't know how fast it went. I think it went every day, maybe. New options had to be given. It was a live ops exercise. How do you think about building that into what you're doing today? Do you think a developer like yourself could have a role like that in an autonomous world?
I think by definition, it's not an autonomous world if I can still do that. So I think of an autonomous world as not having a god, an admin outside the game that can fundamentally change the game for the people inside the game. So for me to it stops, by my definition at least, it stops becoming an autonomous world if there's somebody outside the game that can change what's happening inside the game, or roll a 6 or roll a 5. Somebody's rolling that dice. And so that does cause a problem where you can't really live operate an autonomous world. That's an oxymoron, because live operating sounds like you probably need a degree of centralization to achieve that. And even something as simple as a random number in an on-chain game is hard, because you can look through the code and say, well, what mechanism are they using to create a random number? Oh, well, then I'm going to front run that, and now I know how to win the game. It's really, really, really hard. So then there's a solution of random number. Maybe I'll use an oracle, which is a service somewhere on the internet that gives you a random number if you ask. But then that introduces a point of centralization. So there's a real problem with autonomous worlds. You would love a world that kept throwing surprises at you, but by its definition, it's quite hard for those autonomous worlds to create surprises in that way.
Tim, you wanna tell us, like, maybe talk about what you're doing and working on these days?
Yeah. Let me just say, so far the discussion has been fantastic, because we've covered like hidden information, the issue with having a complete information blockchain game, right? How those tend to be quickly optimized against by the players for money, so they're not as fun. And then when you want to rely on hidden information, suddenly you have problems with things like pseudo-random number generators, and because you can front run them. These are all great points. I've thought deeply about it as well, and very similarly to David, I kind of came to the conclusion that being able to publish rules in the contract, and being able to, or at least be able to put a hash of the rule set in the contract and have a DAO against it, so you can update the rules off chain, and then those rules can be executed by the system. That's interesting, right? But the problem is, and David and Matt have called this out, how do you have an autonomous Web3 game that can essentially make decisions, especially for balancing? And so going down that rabbit hole, we started at Scripted saying, let's take all of our game development knowledge, let's take all that MMO live ops experience, let's try to boil that down into some sort of AI model, right? And then we worked with Yohei Nakajima's Baby AGI system, which is fantastic for autonomous AI, right? Because it treats its system as autonomous agents, tasking itself, checking the task, subtasking itself. It's this a very elegant, and it started out as 200-line system that leads to extremely emergent behavior from large language models. And we said, can we marry these things together and create a system that can't just world build, right? Not just design a world, but can it manage it at the same time? So yeah, that's what we're building. It's called AutoRPG, and it kind of runs the gamut of take a world that you want to create and kind of treat the AIs as gods, right? Are they order? Are they chaos aligned? Are they fighting over the design of the world with limited resources? Are they making decisions about where rivers flow and where volcanoes have erupted, that sort of thing? And then take it to the next level of, once this world is made, well, now there's narrative reasons that these AIs built the entire list of why these regions exist, why these things are important, or what resources happen to be there. And then you can have those things manage the gameplay in the sense that you're publishing a black box AI that's obeying a rule set that's published on the chain, or at least has a hash against it. And that AI has to respect it. And that way you have the appearance of randomness, but there is like a god kind of making a decision, right? More like a game master or a dungeon master, right? And we're very interested in moving towards that kind of on-chain gameplay, right? Because I don't think we've really seen it go forward. But you can imagine that in live operations, like with a mile, if say you've got like a bunch of, what would you say, like primary elements. Let's say you made a game on Web3 about having fire elementals, water, air, earth, all that sort of stuff. And the fire guys end up being overpowered, just like Warhammer Online was when it came out, when the Pyromancer was overpowered, right? We know how games are. There's always something OP. And the game says, well, now I need to generate a special event because I've noticed that all the players are dying more to these guys. So I need to generate a special event that rewards the attacks on the fire people or at least gives people a chance to level up faster so that they can come to parity. But it's not one event, right? It's a whole series of constantly self-adjusting systems. That's interesting. I think that's where we start moving with these worlds.
Can I make sure I understand it? It's the first time I heard it. Sounds interesting. So I talked about a problem where if somebody outside the autonomous world is pulling the levers inside the world, then it creates some centralization. You talked about a solution where within the world there's an AI that's sort of reacting. Is that right so far? Yeah.
Right. A provably fair AI. Let's put it that way. Something that has the same provable fairness as the contract itself.
So then I guess my first question is, why couldn't somebody dig into the AI and be able to front run the AI and say, in this situation, the AI is going to roll a 4, and therefore let's adjust our gameplay knowing that he's about to roll a 4. So how could you not pick apart the source code and predict what that AI was going to do?
So here's an interesting thing about AIs, especially anything that's using like a neural network. Like let's just talk about like deep learning style, right? When we think about a black box, I'm going to put this 2 ways. If you have a copy of the black box itself, right? If you have a copy of the black box itself, you should be able to front run it. But if you have a black box that's being hosted and you can have the black box, such as generating its own ZK proofs, prove that it's operating within the constraints of the rule set, no one needs to actually see the black box to validate the results, right? Which does make it, since reversing black box neural networks is an open problem, a hard open problem in computer science that has not been solved yet, that does give us something interesting to look at. So I'm not going to claim that we have all the solutions here, but I think it's an area that needs to be explored.
So you're saying the AI is a black box that is doing provably legitimate game moves because they're ZK proofs, and you can't reverse engineer a black box that's built from neural networks. Is that right?
And I'm gonna be clear about the reverse engineering the neural networks. The more complex it is, the harder it is, and it's a scaling problem, right? A one-layer neural network is, of course, you can reverse engineer that. When we're talking about these kind of networks, say you crafted one with many, many, many layers, many, many inputs, many hidden layers. That's actually a unsolved problem in computer science, and being able to reverse engineer, much like reverse engineering SHA-256 is a hard problem, right? There are some things that are intractable given time, and that happens to be one of them. Now, of course, someone with a harder computer science background could definitely speak to that, but I do have those guys on call here at George Mason University, so I can talk to those guys at the Learning Agent Center, because we've got some of the finest minds in AI.
All right, I'm going to keep poking holes.
You do it.
And to see if I can. All right, so you can't reverse engineer the black box, or at least it's practically hard to do that. But some person, I should say, has written the rules for that AI, and they exist on the planet. And if you put a gun to their head, they would be forced to tell you.
Yes, that is the XKCD get a password with a wrench plan, right? Yes, that's always possible. On the other hand, if you don't know how the AI works, right? If you've trained the AI as model merges and you can't yourself describe it, but you like the way its output works, well, you've solved that problem, because you yourself as the designer let evolution do its thing, right? Artificial evolution. So that's not as big a problem either. The wrench problem, I don't actually consider that to be an issue, because frankly, if I go and clone a diffusion model right now and have it generate images and then use those images and reverse those through like a clip network to get words back out of it, I could not tell you how that works. I could just tell you the general sequence, right? I can build that, but I can't actually explain how the variable autoencoder is working, because I don't. That's 80 pages of research papers I can't get my head through yet. And yet I can build things with it. That's the crazy part.
Yeah, I'm trying to. Now, I still worry that there's some degree of centralization that
there has to be something, right?
Well, I don't know. I'm just sort of kicking the tires here, wondering whether that introduces any kind of problematic centralization for an autonomous world.
David, let's maybe try another thought experiment.
Yeah.
Let's say that we're able to put a autonomous agent fully decentralized as a black box. You can't predict what it's going to do on the blockchain.
Mm-hmm.
How does that change your thinking about what you're building?
Well, to date, one way of describing this is that you can have two types of MMO. You can have what I call a theme park MMO, which is like World of Warcraft, which is a set of rides that you go on, set of raids that you go on, and once you're finished, then you better hope they build some new rides for you to experience. So, and then there's an emergent MMO, which is really relying on other humans to create emergent gameplay situations. And I suppose EVE Online is a good example of something that I think is at the very light hand of the developer having set it up. So I think that obviously to create an autonomous world, you have to do the latter because we have no mechanism of introducing content in quite that same way, or changing the rules at least. So, but I think that with something like this, then there could be, I could have all players versus some kind of god. That would be interesting, or something that just causes force majeure within the game in a sort of unpredictable but valid way within the game. So I suppose there's less of a requirement to build everything PvP in that scenario.
Right. Yeah, and I'm with you. Emergence is a spectrum, right? World of Warcraft we'd consider it a theme park. It has emergence, right? The flu, the famous flu that went through World of Warcraft and started killing everybody was because of a bug, right? Whereas EVE, or UO, or RuneScape even, are all designed emergent, right? They're not theme parks. They're designed to get the players to provide most of the entertainment value. Yeah, I think with a world, like an autonomous world that we're describing, and I think Matt called out one of the most important parts, is BlazeBall got successful so fast that the team couldn't keep up in any kind of reasonable manner with the live ops requirements. So if there is a god in the background that can handle that load for you and keep the game running and keep it interesting and balanced, that is a great problem to have solved. Right?
Agreed.
And being able to do so on Web3 is doubly interesting because it's unstoppable, right? The game will live forever. Now, that's assuming the AI actually lives on the chain and it's spending the computation cost. If it's a pointer to an AI that's running on someone's black box, it introduces the centralization that David is talking about, no matter how provable fair it is. So it can be stopped in that manner. But at least the load is massively reduced on the humans, right? And you can still, like, for instance, imagine a decentralized autonomous organization that's in charge of listening to the AI. If the AI says, hey, I propose the following rule changes, I'm going to set up a vote. You guys go vote on it, everyone who has voting tokens. And then it executes the rule changes and updates the hash on the contract for the new rules. And then it can start using the new rules if everyone agrees. And if not, if the humans say, hey, no, we know better than this. No, don't do that. Well, then that's another interesting use of a DAO that previously I don't think has been seen.
If I'm understanding correctly, perhaps another interesting outcome here is that outside observers or people, even other participants, would not necessarily know that they were playing with an autonomous agent, right? If it's a black box and it's just a series of letters and numbers attached to an Ethereum address, you don't actually know if it's a bot or if it's a human, and if the emergent behavior is automated or just human behavior.
Well, and I talked about interesting, because I talked about the idea of bringing this omnipresent AI into the world that would change the rule set and keep things interesting. Another way of thinking about it is that each one of those AIs is a player, and you just have so you have a bunch of people on the map. Could be human, could be AI, and I think that. I've already taken the decision that I can't actually stop AIs playing a fully on-chain game. That's
correct. You can't.
So you're better off trying to build a game to accommodate it in some way. And I quite like the idea of trying to create a set of rules for game design that would make for an interesting game if AIs are playing humans.
Yes, I love it. And literally kind of the stuff that we're working on, because for years I've had a headless AI system working, right? And it's only gotten better because of the merger of things like LangChain and the GPT models, right? Suddenly we're able to make decisions, and admittedly a lot of it's very slow image recognition / a lot of text parsing, right? But that's just going to speed up. I think we're in that. If this were the space race, we are in the accelerando, right? Where we're just going to keep seeing the pace of improvement in AI speed increase.
To me, the dream here, and maybe you've probably already thought about this, Tim, is fully on-chain dwarf fortress.
Yeah. Okay. So yes, here's when I got my start doing live events. We had a player base of something like 200,000 people split across 30 servers. So if we did something, and I used to design these, and I was a gameplay engineer as well. So we would put out events where we would do massive invasions, monster invasions that would happen in multiple waves. And these were timed triggers all across this giant landmass, each on the server. And a couple of problems. One, we had to set the triggers by hand and execute them all because game designers doing code. Woohoo! People have strong opinions about that. And then during the actual event where we've got tens of thousands of people online simultaneously all at the same time, all interacting with the systems, the moment one thing goes wrong, man, it massively unbalances everything, and the humans are not fast enough to autocorrect. Suddenly it's a patch a day later, right? Best case scenario. Now, if there's an AI that is in charge of this and sees, oh my God, this item stat is totally ruining this right now in this event, I really need to debuff this a little bit or at least spawn something different. It can do that, and it can react at a speed that the human designers can't match. And yet the parameter that it's acting with was specified by the game designers in the first place. So it's kind of working within this framework, but the game designer is just acknowledging that they cannot anticipate everything. It is like being a game master or a dungeon master for a group of people who are playing a D&D game on TV and decide to just go nuts with it, right? And you're just like, I better be the best host in the world, and I can't anticipate all this. Well, suddenly that issue is reduced, right? And it's very similar and very inspired, I think, by things like what David did with Playmint when you had your item list pushed on the chain for the first time, right? Just putting data on the chain opens up all of these avenues to explore. We're going to do something very similar with a template-based item generator, right? This is stuff that we've seen work in MMOs, but what happens when we let it be emergent with an AI? That's what we want to try.
Let me ask a question about the AI. So one of the things that I understand in Blazeball, which made it fun to take part in, is that the creators were taking off in all sorts of weird directions. And I think they were kind of making up as they were going along, and that was the point, and it was just crazy and funny, didn't make much sense. Now, the AI, do you see the AI as adjusting levels of things and pushing go on buttons, or do you think it's more the sort of Blazeball, wildly creative, here's something you never thought of? Is it just adjusting dials, or is it creating new content?
Okay, I'm glad you asked that, because that's been one of the foundational things that we were confronted with early on, right? I think balancing levers is a deterministic issue, right? That's something that is not necessarily what we would consider deep learning AI based, right? Like AI 1.0 decision trees can figure that out over time. Bayesian statistics can figure out lever pulling. When we started our world building demos, we built a system on top of GPT-4 with LangChain and with a vectorized database. It was Pinecone at the time, to emulate the 5-factor model for human personality, which essentially just sets 5 main human traits and gives you gradients on things like neuroticism or creativity. And it turns into really interesting behaviors, since GPT-4, for instance, actually understands FFM, and you can say, hey, act as though you are a human in these parameters. Now, given that, and given this list of existing things, what would you want to do with it? And one of our demos, when we confronted it with a blank canvas of grass, right, and said, go build something, it made this really neat scene. And it even figured out that it was kind of boring, so it put something in the game in there, some strawberries for some players to go find. And then we gave it a different personality, and it was essentially a lazy personality, and we asked it, make the scene again. And the lazy personality, like, put some bushes in it, and that was it. And it is, I think, possible to improve that model towards more of what you're saying, David, where it's more like Blazeball. And I know this sounds like it's super wishful thinking, but I think we're already seeing it start to develop, right? The main problem, I should say, is that there are a lot of guardrails on systems like GPT-4, right? And so we are seeing people release public models right now without guardrails on Hugging Face. And they're extremely dangerous in the sense that they have very unpredictable or kind of despicable output. Now, if you can put the guardrails back on afterwards to filter the output, suddenly you get even more creativity than what we're currently seeing from the AIs as a service. That's where I'm going with this.
I'm kind of keen to play the despicable one. Where do I get to play the despicable one?
We should talk about it, because see, what's interesting is so to a GPT system right now, and like as long as you give it the proper role, it'll emulate things that are, you know, like dungeon horror, like, oh my gosh, like there's a sarcophagus that's smothering me to death, right? But if you're not careful, it just says, ooh, this sounds like dangerous content, I'm not going to let you think about this, which means it can't make any cognitive, I should never say it's making cognitive decisions. It won't make any good output that can be used, right, by like our underlying system, which is more decision-based. But if you throw it at a despicable model, it has no problem with it. You just have to avoid terrible things that hark back to the original days of MUDs, when game designers were having to learn how to keep the players from truly causing things like sexual violence or other terrible things, right? So there are guardrails that are probably necessary. But right now, we have to find ways to kind of get in the middle.
Got it. Yeah, very cool.
Good. I think this has given me food for thought. The conversation went exactly as I had intended to. Were we setting the scene and then like getting to this point? Now you know what, you know, why like the name that we chose for this was God as a Service. Might not be the right approach. I could see a world where you have decentralized AI models that you can then build your game and link it to, where it's like fixed to like, and it's a separate entity and it's like provably fair. And this is like a centralized, no, sorry, that's a very wrong word to use, but it's like one AI that's multiple games plug in. So I don't know what this turns into, but it felt like something that could solve some of the problems we're seeing with autonomous worlds today.
Yeah, so if autonomous worlds get stale, Tim's pointing to a book that's called what? How to Be a
God.
Oh, that's essential reading. So I think if I understand it right, a possible concern of an autonomous world, it's very interesting insofar as that it's owned by nobody and can live forever. There's a possibility that it just gets boring being in that world, and that the sort of emergent player-to-player interaction isn't as interesting as you would hope, but you've lost the ability to go in and keep things spicy.
Yeah.
But by using sort of God as an AI, you have something in there that sort of shakes things up when things look like they're getting a bit boring. Is that basically where we've got to?
I think so. And that book I was holding up is by Richard Bartle, who's one of the original multi-user dungeon guys, right? And one of the greatest thinkers on this area. And he just points out that as virtual world gods, right, as human game designers, we are often faced with putting our own vision of what reality can be that does not match up with our physical world, right? And humans love conflict. So maybe it's not just God as a service, but maybe it's gods with an S, with a plural, and that this is more about multiple agents interacting that cause more interesting emergent behavior. And that's where I would close out, is that we're exploring things where it's not just one central planner, right? It's more like resource-based competing AIs that still affect the world. That's interesting to us.
Mm-hmm.
It's really interesting, Tim, the way you've approached this. It makes a lot of sense to me, but I find it really interesting because I've kind of been thinking about it the opposite way. Like you've put the AIs kind of in the game as dungeon master, in the world as dungeon masters, to generalize. The way that I had been thinking about it is actually the AIs are more on the outside of the game, creating the front end, creating the content.
Yeah.
So like you have these, like a Blaze Ball, which is a text-based UI simulation where the fan community is the ones creating the visuals. But now we have these great tools for image generation and content, like generative AI, to sort of augment the community's abilities to create interesting fan creations, whether it's art, whether it's like emergent narratives, whatever the case may be, backstories for the players, any of that stuff.
Yeah.
And so my whole thinking was like, put these tools, maybe like fine tune to whatever models you want, or like however you want to do it, in the hands of the players so that they can create the world for you. But there's no reason, by the way, that this approach cannot be combined with your approach, Tim. So we have like AIs on both sides, and then we can get really crazy.
100%. And Matt, let me tell you later about Nifties and how we're doing something like that. So yes, absolutely. Yes, I'm with you.
Fantastic. Awesome. Good. This was a fantastic conversation. I really enjoyed this. Thank you, Tim, Matt, David, for joining me.
Yeah.
And thank you, listener, for listening. And I feel like in a couple of weeks, maybe months, we might have some new thoughts, insights. Tim might have come up with some new cool stuff that warrants another discussion. So until then, we're out and catch you in the next episode.
Thank you all.
Bye.
Thank you.
Bye. Bye.